I want to find the arc length of this parametric curve here, so I'm going to be using this integration formula here. I'm going to be integrating from 0 to 1, the bounds of my parametric curve, of the square root of the derivative of this guy here, the derivative of dx dt. That's going to be e to the t minus e to the negative t squared, plus the derivative of 2t also squared. So the derivative of 2t is just 2, and I square that, putting a dt on the very end. Okay, I'm not going to integrate this as is. I'm going to go ahead and scale and FOIL this out. E to the t minus e to the negative t, when I square that, gives me e to the 2t minus 2 plus e to the negative 2t. And when I take 2 and I square that, I get plus 4. Now this is going to be pretty hard to integrate as well, but I want to point out a pattern we should recognize, that e to the t minus e to the negative t gave me e to the 2t minus 2 plus e to the negative 2t. But when I combine this 4 with this negative 2, I get a plus 2 here, and that plus 4 goes away. And now I should be able to simplify this in a similar fashion. Well, think back a second ago. When it was a minus here, it came from the fact that we had e to the t minus e to the negative t squared. But now it's a plus, so you know what that means, is that we're looking at the same squared term, except instead of it being e to the t minus e to the negative t, it's e to the t plus e to the negative t. And sure enough, this e to the t plus e to the negative t is this e to the 2t plus 2 plus e to the negative t 2t squared out. So it's just a quick thing you should recognize, is that when I squared this out, I had a minus 2, but now that I have a plus 2, it stems from the same idea, but instead of a minus being here, it's now a plus. So I want to go ahead and square root this, which is really convenient because taking the square root of something squared just cancels the square root. So this is going to be the integral from 0 to 1 of e to the t plus e to the negative t dt. Now it's time to integrate this guy. The integral of e to the t is e to the t. The integral of e to the negative t is negative e to the negative t. And now it's time to plug in my bounds. I'm going to plug in 1, plug in 0, and find the difference. When I plug in 1, I get e to the 1 minus e to the negative 1 minus what I get when I plug in 0. Well, e to the 0 is 1, and e to the negative 0 is also 1. Not 0. It's also 1. So I get 1 minus 1, which is 0, which gives me a final answer of e to the 1, which is just e, minus 1 over e. And this is my arc length.